Alright, so question 3.2. Our encryption algorithm was too weak and it got broken. So now we have to upgrade our encryption algorithm to use what's called a rolling key. So a rolling key is when after each stage of decryption, after you've decrypted each character, the key gets updated by some rule. In this case here, the rule we're using is after each stage, the key is replaced with 3 times the key plus 7. Okay, so I'm reusing my solution from the previous video for 3.1 because the solution is going to be very similar, except we're going to have to modify it a bit to change the key. So we do the same load, twiddle, store pattern we did before, but after we do the XOR, we have to change the key. So what we're going to do is we're going to multiply the key by 3. So I'm just going to do using the mul instruction. Well, I'm going to have to put a number in a register first because I can't multiply by an immediate. So I'm just going to treat R8 as the constant 3 register. So multiply the key by 3. So mul R5 by R8. There we go, that does the multiply. We then want to add 7 to the result. So I'm going to take the key and add 7. Now the problem is that sometimes this might overflow, right? The only thing we're interested in is like the bottom byte. Because if I have a very large number, suppose the key was equal to OXFF. So I'll just put this on the line. If I multiply this by 3 and add 7, it's going to be too big to fit inside 8 bits. So what we end up doing is after each stage, we truncate the key and only keep the high bits. So to truncate the key and keep just like the lower byte, we're going to have to AND it with a bit mask. Because in reality, if the key is some number like 55, that's really going to be 00000055. And so if there's like extra stuff here that I want to get rid of, what I can do is I can logically AND this with a bit pattern where the bottom 8 bits are high. So my mask is going to be 000000FF, which is just like the bottom 8 bits are 1s and everything else is 0s. And then when I take my key, what happened to my key? So 00000155. If I take this key and logically AND it with this mask, the result will be the new key will be the same as the old key, but you throw away anything that doesn't exist in the lower byte, or the lowest 2 hexadecimal digits. So we need to bit mask, so we can just do a logical AND of R5 with OXFF. Now technically speaking, you don't really have to do this, because when you end up XORing when you XOR the key with the byte you load, the top half of the byte you load will get mucked up. But when you do the strb instruction, if you try to store something too big, it too will be truncated. So for example, if I have R0 contains OX12345678, and I execute an strb R0 into where R1 points, I'll only be storing the 78, and the rest will be thrown away. So when you store, because our registers are really a word in size, right? Our registers are really 4 bytes large. So when I store a byte, I only store the bottom half, and the rest gets discarded. So technically speaking, I don't have to do this instruction, but it's probably good practice to truncate the keys, so that way we can see when we run the code what's happening to the keys it updates. So now that we've updated the code so it's got the new rolling key instruction, we can run it again and see what happens. And hopefully with our new secret message, we'll see something interesting happen in the memory viewer. So we'll run it with debug. And debug is just starting up. Here we go. So we'll skip ahead to main. And so now I've got a different secret message here, which is just displaying as just junk. So we'll skip ahead to the part where the key updates. So we'll just fly through the code till we get to here. Play. Alright. So R2 contains our key, OX55. We XOR the key with the secret message. So the secret message gets decrypted to 53. And then I take my key, I multiply it by 3. Sorry, my key is here. Whoops, I've multiplied the wrong thing. The key lives in R2, so I should be multiplying R2, not R5. The tricky thing about assembly is your registers aren't really labeled, so you have to sort of like mentally juggle in your head what register represents what variable. And you can see there, sometimes I make a mistake myself of loading the wrong thing. So let's try that again. Turn on the debugger. There we go. So we'll fly through the code to get to main, fly through to get to the XOR. So our key is stored in R2 after we do all the other instructions, so 55. So I decrypt the first byte of the secret message. I then multiply the key by 3. I add 7 to the key, and then I bit mask it out so I only keep the bottom byte. You can see here the key is now updated to 6. I then store the decrypted byte back to memory, and you can see the first letter of the message is an S. So if we just let this code run really fast, I'll remove this breakpoint here, and we just let the code run, we can see the message once again decodes to space grow fast.